Hello, I'm Hazwan. Today I would like to explain and show you guys the simulation about the source free of RC circuit.
This is basic formula of source-free RC circuit. We can use KCL by IR plus IC equal to 0, where IR depends on Ohm's law and IC depends on capacitor law. This is first example of source-free RC circuit. There are two resistors and one capacitor in parallel and one series resistor. The switch in circuit is open at T equal to 0. Find V total for the T is larger than 0. How to find the total voltage? Let's discuss together. Firstly, we must find the voltage capacitor. To find the voltage capacitor, we have to simplify the circuit by parallel the resistor. For your information, in DC condition, capacitor must be in open circuit. Using voltage divider rule, we can find the voltage capacitor, which resistance parallel to capacitor divided by the total resistor and multiply by the voltage supply. So we get 8 volt for the VC. Okay, we move to T larger than 0. When T larger than 0, the voltage supply and 6 ohm resistor are not connected to the circuit because the switch are open. Then we can find the tau. Tau can be defined by resistance multiplied by the capacitor. Finally, we can find the voltage total by using the equation voltage total equal to voltage capacitor exponent power of negative T over tau. This is our circuit simulation using multimeter and oscilloscope to get the total voltage and waveform of charging and discharging capacitor. Let's see the simulation in the next part of the video.
Created using Powtoon.
Here I will show you our circuit simulation using multisim. I will let the switch close at the first and run the simulation. At this condition, the power supply will provide the voltage to the circuit. As we close the switch, we can see the graph immediately increase, which means the capacitor is charging. We will wait until the capacitor fully charged. Okay, here we will see the voltage at oscilloscope and voltmeter are same and stop at 8 volt. So capacitor now is fully charged and we will open the switch to discharge the capacitor and see the graph. The graph will continuously decline, which means the capacitor is discharged. At this condition, the capacitor is provide the voltage to the circuit until the capacitor fully discharged.
Hello, I'm Anis. Let's continue with the second example for source-free RC circuit. The switch in the circuit has been closed for a long time and it is open at T is equal to 0. Let's find the V total for T is bigger than 0. In this condition, T is lower than 0. The switch is closed. Let's find the V capacitor for the circuit, whereas V capacitor is same as V initial across the capacitor. Please remind the basic characteristic of the capacitor where the capacitor is act as open circuit to DC. Apply voltage divider rule to find the voltage capacitor. Ignore the resistor because there is no current flow at 1 ohm resistor. So, the voltage capacitor is equal to 15 volt.
How about the condition when T is equal to 0?
Since the voltage across capacitor cannot change instantaneously, so T is equal to 0 is same at T is lower than 0. So the voltage across the capacitor when T is equal to 0 is still 15 volt. Okay, let's move to the next explanation where T is bigger than 0. The switch is open. So you can find the time constant where tau is equal to R multiplied by C. It became a series circuit when T is bigger than 0 that contain resistor and capacitor. Find the R total and use the formula tau equal to R multiplied by C to get the time constant. So, the time constant is 0.2 seconds. After you get all the values, let's find the V total by using the formula. V initial is equal to 15 volt and time constant is equal to 0.2 second. So the answer is 15 exponent to the power of negative 5t volt.
How to find the initial energy stored in the capacitor?
To find the initial energy stored in the capacitor, you need to use the formula where the energy is 1 over 2 multiplied by C equivalent multiplied by voltage initial to the power of 2. By using the value from the circuit, V initial is equal to 15 volt and C equivalent is equal to 20 millifarad. The answer is 2.25 joules. Good luck!
Hi, today I'm going to show you how to make a circuit simulation for source-free RC circuit using multi-sim software. First, the component that we use is resistor, 1 ohm, 3 ohm, and 9 ohm. And then we use a power supply, DC power supply. For the capacitor, we need to take a bit of polarity, which is 20 millifarad. And for switch, we use switch SPDT, single switch. And then to know the value when charging or discharging, you need to connect the circuit with multimeter. And then to know the charging and discharging process, you need to use oscilloscope check to the circuit, then connect to the capacitor. Graph is to see how the charging process. Then you need to run the circuit. For the charging process, when you put a switch and the switch is in condition 3 smaller than 0, which is the switch is closed, it means the capacitor will charge until it reach 15 volt. You can see from the graph, it's increasing to charge the capacitor. Now you can see the capacitor is fully charged to 15 volt. Then for the discharging process, when the condition T bigger than T is bigger than 0, it's open circuit, which means the circuit is in discharging process. From the oscilloscope graph, you can see the graph is increasing. That means the process is discharging. Okay, that's all for the circuit simulation source free RC circuit.